All right. I just noticed I have 45 minutes like 3 days ago. I also sold my house on Friday, so I'm like going to be talking really fast during this session. So the Web Dev's Toolbox. I think before I start talking about tools, I need to tell you a little bit about where I'm coming from, because you need to choose tools that are appropriate for your projects and your company. So I run a shop called gskinner Incorporated, very inventive name. And we're about 17 people, so we're sort of a mid-sized shop. And we work on mid-sized projects for some pretty cool clients. Things ranging anywhere from about, maybe 3 man months up to a few man years. And I've been doing this for a long time. I've been working on the web for over 15 years. And starting this talk really got me thinking about what this talk would have looked like 15 years ago. First of all, it would have been black and white, because that's the way it was back in those days. We would have been called webmasters, because man, we mastered the web back then. I mean, it was a way cooler title back then. Thing is, it was pretty easy to master the web back then because there wasn't really much to it. If I had been giving this talk 15 years ago, I would have shown you how to use a text editor, shown you how to use an FTP client, and we pretty much would have been done. I would have been saying thank you, good night, right about now. But things have changed, and they've changed immensely over the last couple of years. We have a literal plethora of tools. We almost have too many tools, and it can be very difficult to figure out which ones work and which ones don't, and which ones fit best in your workflow. The kind of scary thing about this is that I talk at a lot of conferences and I talk to a lot of web developers, and I'm still finding quite a few web developers that are stuck in that same place 15 years ago. They're using Notepad++, they're uploading stuff with an FTP client, maybe hosting it on GeoCities. And so I thought this talk would be a good way to sort of introduce people to some of these tools. And that's really what this is going to be. I have 45 minutes. I'm not going to dive deeply into any one tool. I'm just going to kind of skim along the surface of a whole bunch of different tools. We'll take a little plunge now and then, get our toes wet. But really, my goal in this talk is to introduce you to the tools that we use, right, at gskinner. And hopefully, you guys can take that away. I mean, we have this wonderful thing called the internet now, and it's so easy to dive in and get the details once you know that these things exist. It's also worth noting that, again, these are tools that we use, and this is just some of the tools that we use. There's every single thing I show you, there are multiple alternatives to it. You might have one that you prefer, and in fact, in a lot of these cases, we'll use multiple versions, like multiple types of the same tool, depending on the project and the results that we need. What we're looking for in our tools is we want them to provide consistency and productivity. Right? We want consistency both internally and within the group. So personally and within the group, we want it to enforce our code standards. We want it to enforce our workflow standards. And ultimately, not only do we want higher quality output, but we want more predictable output. Right? We want the ability to be able to predict or estimate how long a project is going to take, and that reduces the stress on our team. And of course, we want productivity. Right? Developer time is a scarce resource. And so anything that we can do to improve the amount of work that one developer can do, the better we're going to be. And tools work mainly by reducing the wasted time on mundane tasks. Right? They don't make us smarter. They don't make us better at architecting things necessarily. But they do take away all those little sort of wastes of time that don't require any brain power, and they let us reprioritize that time to activities that have a higher payoff. Things like thinking, planning, learning new things, and testing. However, tools aren't free, right? They require some investment. And I think this is what holds back a lot of companies from using tools. There's always going to be this initial period when you bring a new tool into a company where you have to learn how to use that tool. And that can be a dedicated activity that means that you're not productive at all, right? You're not working on a project. And Eventually, you're going to learn that tool. If it's a good tool, you're going to get right back up to the productivity level you were at, and you're going to get past it. And over time, as you get more and more familiar with that tool, you'll see that growth continue, albeit at a much slower rate. So you wind up with a productivity graph that looks something like this. We generally aim for tools that are going to take us about a week or less to learn, get back to the same level of productivity, and continue on. What's maybe more important is the output from that productivity, right? How much we're actually getting done in time. And so this takes a little bit longer to catch up on, right? We have all of that time where we've been doing nothing, and we need to catch back up to the productivity or the output we would have had if we'd just been working straight through. But this is multiplied because now we're dealing with a steeper slope on this graph, right? And it's also multiplied when we have more people. The more people we have on the team, we can take individuals, make them domain experts on a tool, have them teach the rest of the team, and really minimize that initial investment and sort of amortize it across the whole team. But it's important that you're aware that tools don't come for free. One other thing that we need to balance with tools, wow, that's almost the same color, is productivity versus accessibility. So the slightly more yellow line represents the accessibility. How easy is it for you to bring a new developer onto your team and get them running with your tools? And as you add more and more tools, it becomes more and more difficult for that to happen, right? You bring them into this really arcane system where they have to learn 20 different tools before they can write a single line of code. You're balancing that against productivity, right? More tools generally results in better productivity. For us, because we work on these sort of medium-sized projects, we find a sweet spot sort of somewhere in the middle, where there is a little bit of a learning curve, but not a lot, right? And I like to think of this as sort of non-prescriptive tools. We look for tools in general, not always, but in general, where if you come into one of our projects and know nothing about our tools, you can still go in, edit the code, output it, get it onto a server, and have gotten something done, right? You can fix an emergency if you need to without knowing our tooling set. Other industries are going to have different requirements, right? If you're building a product, long-term project, the enterprise environment, you might need more tooling. It might be worth that much higher investment to get someone ramped up on your system. I've seen some pretty arcane build processes that you really need to spend a few weeks to figure out how they work. If you're just cranking through Drupal sites, you might not need almost any tooling at all. It might be, or if you're a small shop that just churns through interns, please don't talk to me if you are, because I think that's a horrible business model. You might not care about educating people or getting that extra productivity because they might only be around for a few months. So let's actually look at some tools. I've kind of broken them into 4 overlapping categories. And the first one we're going to look at is sort of the core tools that you need to work with all the others. And the place we're going to start is sort of right at the middle. Well, this is still a large abstraction from the middle, but we're going to look at the command line. Command line nerds, this is the only command line joke I could come up with. And I'm not going to explain it. So why do we want to learn the command line? Because not everything has a GUI, and this is especially true right now. And we'll talk a little bit about why that is in a second. A lot of web developers come from sort of a non-traditional programming background, and they kind of see the terminal or the command line like this, right? This very complicated thing. You need to know a lot of different commands to work with it. I was actually kind of like this. I grew up on a Mac, and I had this philosophy that if it's worth doing, it's worth having a GUI for it. And so I'm pretty cynical when it comes to the command line. But over the last few years, I've really trained myself to use it. And I've realized you only really need to know a couple of commands, and you're good to go. The first is how to get help. So if you type help into your terminal, you're going to get help. If you want help with a specific command, you can type man and then the command, and you'll get the manual for that command. Past that, almost everything that you're going to do with these tools is well documented. The only thing that they really assume is that you know how to get into your working directory. And so all you really need to know, besides what's going to be in the documentation, is CD, which is change directory. It's also good to know a few little shortcuts, which can be hard to track down. It's not going to be in the help anywhere. For example, you can type CD space and then drag a folder into your terminal or into the Windows PowerShell, and it'll just insert that path right into your command line. Likewise, you can start typing a directory name or a path and hit tab, and it'll auto-complete based on what you've typed so far. You can use up arrow to scroll through the recent commands that you've issued. And this is one that's fairly new to me, but has been incredibly useful, which is hitting Control-R to search through your recent commands. So you can just hit Control-R and start typing in, say, Sass, and it'll bring up the last Sass command that you issued. You just hit Enter, and it'll run. This isn't available in Windows PowerShell. I haven't tested yet if it's available in Cygwin, but it is in Terminal. And lastly, if you fire up a local server or something, which is an ongoing task, and you want to shut it down, Control-C will tell it to close and give it some time to clean up. Control-Z will just kill it off, but it doesn't allow it to clean up. So really easy, and you're going to need this to work with most web tools nowadays. And part of the reason for that is Node.js. Node.js came onto the scene as a JavaScript-based web server. And it's great for that, but I think really its more important role nowadays is as a headless JS platform. It allows us to execute JavaScript code as sort of miniature applications right off the command line. And so suddenly, anyone who knows JavaScript can write these little JavaScript modules that have a lot of functionality and act a lot like a native app, and you can run them right off the command line. One of the things that comes with Node.js is the Node Package Manager. And it really easily allows you to install modules that other people have written. So for example, if I want to install Uglify, which is a minification program, I can just say npm install Uglify, and that'll install it into my current working directory. It becomes more interesting, though, especially when you're dealing with multi-person teams, to use package.json files. So I can include a package.json file in my project, and it can define all of the dependencies that my project has. So for example, I want the UE compressor included here. I want Sass included in this project. These are all things that I'm going to need to work with this project. And then someone can just come in and say, npm install. And it's going to run through that package.json and install everything that I've said it needs, plus all of the dependencies of all of those modules. And so I'm set up with the build environment that my whole team has, very simply. So that's the core. Let's get into the code. Now, before we do any coding, we probably want to set up version control. If you're coding without version control in this day and age, you're a crazy person. A crazy person, I say. We use Git almost exclusively. Obviously, there's other options like Subversion. And it offers a ton of benefits. Basically, this is infinite undo, right? Where your IDE or your code editor lets off with undo, this Git picks up. It also provides you with remote backup, which saves you from hardware crashes and things like that. And it facilitates team collaboration. Really easy to work with. It can be a little daunting when you're first looking at it because there's a lot of commands, especially if you're trying to use it on the command line. Basically, you can make some local edits to some files. You can stage them and package them up together into one unit. And then you can commit them into a history of edits. And then you have the ability to walk up and down through that history to see what's changed, to revert changes. And so again, you can see that this is sort of like this unlimited undo that works at a file level. Git, though, is a distributed version control system. And every single web talk has to have a cloud diagram. So I've made sure to include one. And so every user, so we can set up a remote repo, and we can have a bunch of users with their own local repos that point to that remote repo, and they can all collaborate together We can push our changes into the remote repo. We can clone a remote repo so we have an exact copy of that whole history of a project. We can pull other people's changes. We can decide, I'm going to work on something that's a little bit dangerous, that's going to involve a lot of different files, might not work out. And we can say, OK, I'm going to take a full copy of the trunk of this project, and I'm going to make a branch. And I'm going to work within my own branch and keep it isolated from what everyone else is doing. And then when I feel like it's stable enough, I'll merge it all back in at once. And this is really powerful. It allows you to isolate different pieces of work as you go along. There's also a small feature in Git that I think is kind of underutilized, but I find really useful, which is stash. And stash basically just says, take all of my current open edits and stash them away into essentially a commit that doesn't go onto the history. And then when I feel like I want to pull them back in, I can unstash them. And so I can be working away on feature A, and someone can come in and say, hey, we have this priority bug. It needs to get fixed right now. You know, it's taking down the server. And you can say, OK, I'm going to stash off the feature A edits that you've made so far, edit the bug, fix it up, commit that back in, and then unstash the features and be ready to go. And you can do that multiple times. It's a really powerful feature, and it's really easy to use. Of course, you can use Git on the command line. This is a tool, though, that I don't really recommend it. There's a lot of complexity to Git. Not to say that you can't use it on the command line at all. I mean, once in a while, I'll jump into the command line if I have to. But there's a lot of benefit to using a visual Git client. I like Tower. It's probably one of the priciest tools. Anything that costs anything, I'm putting a price up. I'm not trying to sell any of these things, so I want you to know when something has a price associated with it. One of the big benefits of using a visual editor is the fact that it's visual. So I can go through and I can do things like cherry picking, where I can see, OK, so I've made some changes to this doc view JavaScript file. What did I change? And I can see here, oh, I added all of this stuff. I got rid of that. I can cherry pick changes. So I can actually say, I want to commit this one chunk of a file instead of the whole file. I can look at the full history of a file very easily, right? I can say show file history. And these are all things that I can do on the command line, but they're just a lot easier to do visually. They're a lot easier to sort through. Look at the network graph. I can see who's changing what, and go back through all of my commits. So feel free to use the command line. This is the one tool that I really think is valuable to have a good visual GUI on top of. So something like Tower takes care of the client side when you're dealing with Git. On the server side, so on your remote repos, you might want something there as well that lets you administer these repos. It lets you assign privileges and things like that. The popular and well-known one is GitHub, of course. Another alternative that we use internally is GitLab, which is basically a self-hosted version of something very similar to GitHub. Again, it lets you do a lot of stuff that you would expect to do. One of the things that I really like, one of the features I really like is webhooks. Webhooks basically let you say, anytime something new gets committed to this repo, I want you to ping another server and let it know that there's been a change. And so we use this to automate things like tests, builds, and deploys. So for example, if I commit to one of our GitLab servers, it can run our unit tests, make sure that it passes all of the tests that we require. Then it can run our build and get it ready for deploy. If it's tagged, so if that commit has a version associated with it, it will deploy it to our public server. And if not, it will deploy it to our private server, right, our stage server. And so a client can go and look at the in-progress work, or we can say, no, this is ready to go. Let's push it straight to the public server. And so all of this becomes transparent. And it gets rid of that FTP client that we were using 15 years ago. So now we're ready to start coding. What do we use to code? Well, this is obviously hotly debated, and my advice is pick whatever you think works for you. I actually use 3 code editors on a regular basis. I use Sublime for sort of mid-size or smallish projects that I don't have a lot of commitment to. I use Text Wrangler for those times that you just want to quickly open a file and change one line in it, because it launches in like a half a second. But most of my coding nowadays is done in WebStorm. And as I started doing this talk, I realized it's kind of sounding like a WebStorm sales pitch, which is not at all the intention. But WebStorm is really, really robust. So you'll see as we go why I'm disclaiming that I don't work for the WebStorm team. So why do we want a good code editor? Because we want better code, and we want to be doing less coding. I recently tweeted that the easiest part of coding is writing code, right? Again, we want to spend more of our time thinking than we do on writing code. Oh, there we go. I have a slide for it. That's what I was just saying. But I really think this is true, right? Again, we want to try and accelerate what we're doing and take out all those mundane little bits. We want to reduce the amount of typing we have to do, reduce the amount of like easy, stupid testing that we can do so that we can focus on the hard parts. And so again, I've really focused on WebStorm. It's $49 for a personal license, $99 for a commercial, like transferable license. And the reason that we've sort of settled on it is that it's completely cross-platform, works great on both Windows and Mac. But kind of more importantly is that it has a shareable configuration. And so we can set up the entire environment in WebStorm and share that through the whole team and know that everyone is coding to the same standards and has access to the same templates and things like that. It's crazy feature-rich. I always swear I will never type code on stage, but I'm going to just really quickly. And this is like the most awkward podium for typing, so bear with me here. So I have this index file. I'm just going to show you a few things in WebStorm. So first off, I want to link in a style sheet. I always forget how to do it. I mean, I've been writing HTML for years. I never remember this. So I set up a custom template. So I can just say CSS tab, boom. That's how it works. OK. Then I can start typing in whatever it is. OK, yeah, it's in the CSS folder. And it's called, yeah, styles. Good, we have that. OK, let's just command click here. Yeah, that looks like what I wanted. Now let's add a paragraph tag. I'm going to add a class. And you can see that it's actually gone in and found all the classes that are relevant to paragraph tags. So I can say, yeah, let's make this a title. And I'm going to say, hello. I'm going to use something called Emmet, which is sort of a code accelerator, to do a subtitle. So I'm just going to say p.subtitle tab. And that writes out my whole paragraph class with the subtitle there. So let's say ways to say hi. I'd like to see what this looks like. So I'm going to hit the debug button. Actually, first I'm just going to split this over, hit the debug button. And OK, so that's looking OK so far. We can see that JetBrains is debugging inside of Chrome for me. So I'm going to do a little bit more editing, and you'll see it update live in Chrome. So I'm going to use Emmet again, and I'm just going to kind of go nuts with it. So I'm going to say, oops, I want an ordered list with class listing. And it knows that ordered lists are comprised of list items. So I don't need to put in list items. I'm just going to say all my list items should have lorem ipsum, say three words. And let's do 5 items. And boom. So that just threw in all that stuff for me. Nice and easy, right? It accelerates everything that I'm doing. Now I want to actually put some code in. So I'm going to create a script tag. And I'm going to say this is hello.js. It underlines it to tell me, hey, there actually isn't a hello.js. So I'm just going to hit Alt-Enter and say, yeah, you can create that for me. Boom, I have my JavaScript file. But I should have put that into my JavaScript directory. So I'm going to drag that up there, tell it it's allowed to refactor, and it's nicely updated that for me. I have a nice class template already set up that I use for most of my code, so I can just put in class, and it puts in this smart template for me. It grabbed the name of the class from the file name, so it's already going with hello, that's fine. Yeah, my name's fine, date is fine. Parameters, so I want to say name. You can see that that's inserted into my initializer, and it's showing up down here, and now it's saying, well, what do you want to do in your constructor? So we'll just say this.name equals name. I need to actually create that name property. I'm not going to bother updating my JS docs here. And I want a method called say with a parameter what. And we're just going to make this console.log what and this.name. Okay. You can see that it's underlining this because it's saying, well, that doesn't match up with the parameters you have in your documentation. So just to make it shut up, we're going to update that. And we'll say that it's a string. And that's say. And so now I have this class in place. Let's actually use it. So I'm going to put in another script tag. And I'm going to say var. Let's just go with hello equals new. And it knows all about that now. What do I need? I need name. OK. So we'll go with world just to stay with tradition. Everyone see this? I'm just going to, oops. I always forget how to bump up my, there. So now I'm just going to say hello.say, and we'll just say hey. All right, oops. All right, and because we're doing a live edit, I don't know if the people near the back can see it or not, but we can actually see our console updating down here because it's being fed back from Chrome. And so we can see hey world showing up back here. If I switch to hey, it's being refreshed there. But I want to add an exclamation mark, so I'm going to command click on say, which will take me to its definition. I'll add an exclamation mark here. And I'm actually curious whether that's going to affect anything else. So I'll right click on this and say find all usages for me. And no, it looks like the only place that that's being used is that one line in my index. So you can see how this tooling can really accelerate the work that you're doing, right? You don't have to be doing all of those little tasks that take up time as a developer. You can focus on actually writing good code. So I kind of mentioned this already, but this is entirely accidental. But it turns out that basically every other tool that I'm going to show you is supported by WebStorm in one way or another. WebStorm is very agile. They add features like mad, and every time I think I've come up with a new tool that they don't support, the next release seems to add support for that tool. So you'll hear me saying, yeah, WebStorm also does this. For example, it has a built-in terminal or built-in command line. So what if we go past what our IDE can support? What if we want features that aren't available because we're limited by our language, right? JavaScript is very dynamic. There's only so much we can do in terms of type safety and stuff like that. We can get into abstractions. So TypeScript is a great language abstraction. It's a superset of JavaScript, which means that all JavaScript is valid TypeScript. And it allows you to layer on stuff like type safety, class and inheritance, interfaces, and it does all of this within the structure of ECMAScript 6. So it's forward-looking. So in theory, TypeScript that you write today should be mostly compatible with the JavaScript you write in the future. The other thing I really like about it is that it's non-invasive. You can write side-along definition files. So you can write your JavaScript, and then you can write a definition file that adds all the type information and not have to modify your original JavaScript. So that hello class that we wrote in TypeScript would look like the top part, So we're defining a class, we're defining a constructor, and we're defining a method. And if I wanted to keep my vanilla JavaScript and just add that typing information for the pre-processing, then I can do an export class, and I can associate this back to my JavaScript, and it'll use this for the type information. Similar to TypeScript, TypeScript is a JavaScript preprocessor. Sass is a CSS preprocessor. And I honestly refuse to write CSS without it. This is one of the few this is one of the few tools that we use that is completely invasive, right? That you cannot really edit what we're doing without getting to know Sass, because I personally hate CSS. And it gives us all kinds. It gives us all kinds of. Again, it's a superset of CSS, so all CSS is valid SCSS. And it gives us all kinds of lovely new features in CSS that have been lacking so far. So let me just show you an existing project of ours called regexer, just so you have an idea. Again, not going to go into a lot of detail. But here you can see the nesting that Sass provides. So I can say, I have a doc class, and any title class, any element with a title class within a doc class will get these styles, right? A much cleaner way of going through this code. You can see things like variables. So I'm pulling in this as a variable. I'm using an include, which is basically a function. In this case, I'm using it to deal with browser compatibility, right? Browser prefixes. So this is creating all of the browser prefixed calc statements. And you can also extend things. So I'm saying these two classes will basically inherit all of the functionality from the user select none class. And we can do some pretty powerful things with this. So for example, if I just open up regexer here, I'll close this off for now. You can see it has this lovely gray and blue theme to it. And if I, let's jump in here and go up to the top. So if I wanted to do horrible things to this, I don't know, I can make this green, and I could make this red. And what you'll see is that these two color values are propagated throughout using color manipulation tools like darken and lighten. And so if I jump into my terminal here, and Control R should help me out here, grunt Sass. So I'm rebuilding my CSS from my Sass file. Ooh, that is horrifying. But you can see how those two color values, those variables, flowed through the entire project. And this means that we can do exciting Halloween versions of a regular expression tool. All right, let's get rid of that so that I don't have to look at it when I show you new stuff. Man, do I really only have 10 minutes left? Okay, so the last thing in production, which a lot of people would think about as testing, is linting. So you can lint CSS, you can lint JavaScript. I really like gskinner. Again, a lot of people use this as sort of a post-processor or a testing tool where they'll write a bunch of code and then they'll run it through a linter. And it'll come back with all these errors, and then they arduously go back through their code and try and resolve the errors. It lets you know about common coding mistakes. It lets you know about stylistic issues. There's a lot of options in gskinner. You can see partial list of them as they show up in WebStorm down the left-hand side. So everything from the type of quotation marks you use to things like making sure you use strict. I prefer using hinting in a real-time basis. So Many editors support this, but for example, with WebStorm, you can see down the right-hand side, it's flagging errors. And when I roll over them, it's saying, this is a JS-hint error. This identifier, super_show, isn't in camel case. And you told me that you prefer your variables in camel case. I find this much more useful because I can make these edits as I go rather than just getting a huge block of errors at the end of coding. So this takes us into testing. I'm still kind of shocked how many web developers test off the file system. You really can't do this effectively. It doesn't let you know how your site is going to behave on the web. So make sure that you're always testing off a local server. On Mac, it's super easy. It's just this little tiny line of code on the command line will run a simple server on your current working directory. If you install Python for Windows, you can do the same thing. You can also use a GUI for this, so like MAMP or WAMP will set up a local server. WebStorm by default tests into its own local server. Once you're running on a local server, you want to actually start testing your code. And the best place to do that nowadays is browsers. I mean, browsers used to just be a canvas that we kind of drew our work onto. Now they're very sophisticated dev tools. We tend to use all of the browsers and all of the different dev tools, but the most common one is probably Chrome. It's available everywhere. It has a really robust set of tools, so we'll focus on that. A lot of people only consider their only real debugging tool to be console.log. And it's funny because even just console has a lot of depth to it. One really simple thing that it can do, which is super minor, but I kind of kicked myself when I found it out, is you can do multi-line inputs into the console by using Shift-Enter, which comes in really handy when you want to define those little quick functions that let you test something in the browser. But there's a lot more to it. There's a whole bunch of methods on console that a lot of people don't explore. So for example, let's take over again here. We have things like console.clear, console.time that let you time a block of code, console.group that lets you format your content, console.count, which iterates a counter every time it gets called. And you can use these things to develop some pretty nice little reports. So if we look at the console output from here, hopefully you guys can see that. Down here I have these nice collapsible groups. It's telling me what's going on. I can jump into these results. I have a warning for something that came back as a 404. And this whole process has been timed. And this is precision timing, so it's sub-millisecond timing. We use that actually, for example, in hideous green regexer to get little logs on what some of our most performance-intensive methods are doing, right? So this is breaking down what an update is doing. Okay. The next, used to be able to command tab out of Keynote, and now you apparently can't. The next panel is we're looking at is elements. So let's reload this, and hopefully we don't wind up with red and green. So the elements panel shows us the DOM, and it's important to differentiate between our HTML and the DOM. This is the live DOM. This is after JavaScript is done manipulating things. And so I can come in here, I can choose my inspect tool, and I can say, I want to look at this title. I can pull open a console down here by hitting escape. I can do some kind of neat stuff on the console, like I can put in $0, which is going to match the last thing that I inspected in the elements panel. And so you can see I can dump this out as a JavaScript object. I can make edits. So let's rename this to like Web 3.0 Monkey Pants. I can drag stuff around. I can edit styles. So let's make this like 0.5 EM. And so I can really manipulate this a lot. again, this is not my HTML, but if I really want to output it as HTML, I can copy it as HTML. I can also search for stuff in here. So I know there's a Google Analytics script in here, and I can click this to take me into the sources panel, which is the next place we're going to look. You can see that this has been minified. If I want a better view on it, I can click the pretty print down here and get a nice view on that code. And I can also do multi-file searches, again, hitting escape, and I'm going to search for this update method. I can jump into it, which I can't see happening because it's down here. And, oops. This is the update method I want. Double-click that. And I can see this code. I can add things like breakpoints. I can also edit my code here, and I can actually right-click and save code back out. I can add directories as part of my workspace, which allows me to just work on these files and save them back to the local file system. And I can add cool stuff like conditional breakpoints. And the neat thing about conditional breakpoints, is that this code will execute, and only if it returns true will it break. So you can actually use this to non-destructively inject code in. So I'm going to call console.profile, and I'm going to have it profile my update function. And so this is going to start a profile, and then when it gets down to here, I have a profile end, console.profile end call. And if I run this, what we hope is that we have this update profile that's been created in my profiles list. And this allows me to come in here and see everything that happened during that time frame, right? From when that first conditional breakpoint was hit to when the second conditional breakpoint was hit. And so I can actually look through this flame chart and see, oh, okay, this method, window.codemirror.codemirror.operation took roughly 30 milliseconds. How does that break down? Well, a lot of that time is going into update display. And so I can get a lot of details in this very easily. So we just looked at sources, looked at profiles. These ones I'm going to go through really quickly. So network just lets you look at what was loaded, how long it blocked for, how long it took to actually establish the HTTP connection versus loading things. The timeline, which lets you take a granular look at everything that happened over a certain period of time, whether it's rendering or JavaScript execution, also memory growth over time. Profiles, which we just looked at, but which will also give you memory profiles, so you can look at the objects that were created or destroyed in a given amount of time. Resources, which just lets you edit cookies and local storage and things like that. And finally, audits, which is basically just a linting tool. The last thing that every web developer nowadays should learn is how to connect your device to your browser. And so each browser, IE will connect to a Windows Phone device, Safari will connect to an iOS device, Firefox will connect to a Firefox OS device, and Chrome, of course, will connect to Android. And it'll allow you to control the browser on your phone, as well as get all the debug information that you would get off of your desktop browser. Really critical in this day of multiple devices. So the last piece, I'm probably going to go like a few minutes over, but that's why Sean puts me before lunch, is because I always go over, is building. So one part of building is minification. I'm not really going to go into it because it's not a workflow process. It's just a task that we have to get done. The only thing that I do want to mention about it is a little trick that we use with Uglify.js. Uglify.js, you normally look at it as this thing that makes your code all nice and compact. But it has this neat feature where you can call it with the define parameter and the compress parameter, and you can have it inject a global level variable and then have it strip dead code out of your JavaScript. And that lets you write statements like these ones up at the top, where when debug is specifically set to false, these will all become dead code and will not wind up in your final output, right? So all of this code that is at the top will not be put into my final minified file. And this lets us write a lot of debug code. So for example, those those tests I showed you in regexer are all written in this fashion, where they have the debug and prefix. So when debug is specifically false, that will be stripped out, and none of that will make it through to production. We have all of these tools. It would be nice if we could actually tie them all together, and that's where something like grunt comes in. Why? Because we can do all of this with one command. We can write a grunt file that will take our production code and get it ready for deploy. It'll run tests on it. It'll zip what needs to be zipped. It'll create the docs that need to be created. It'll commit things to Git. It'll set up a local server, and it'll make it all ready to run. So let's take a quick look at that. I swear I am almost done. So grunt is a little bit tricky to get into, but once you get the feel for it, it's quite easy. It comes with all kinds of existing modules that already do a lot of the things you want to do out of the box, and you can just load those in. So here I'm loading in Uglify, for example, and I'm loading in Sass. And these just become tasks that I only need to define the configuration for. So for example, Uglify, I'm saying, we're going to set that debug parameter to false. We're going to strip out dead code. These are the files that we're using. So we can define the configuration for those built-in tasks or those existing modules. We can also register custom tasks that we can write in JavaScript, or that can be like aggregate tasks. So tasks that basically just run a bunch of other tasks. So this is our build task that goes through and does a whole bunch of different things to get things ready for deployment. And of course, you can write helper functions in JavaScript. And so this becomes really powerful. It means that I can do a full deploy just by saying grunt build. I'm not going to do that because that'll kick off this big process. Again, WebStorm actually integrates grunt. So you can see all the grunt tasks that I have in that file right here. And I can just click on them to run them. OK. Of course, designers might be happier using CodeKit, which provides sort of similar functionality, but it's not going to give you the same level of granular control over the configuration, over the versions that you're using, et cetera. And so what we do to really collaborate with designers and get them using these grunt tasks instead is we use command and bat files, which are basically just double-clickable command line commands, right? So we'll commit with all of our projects a run.command and a run.bat that basically just runs whatever processes we need to run. And that way our designers don't have to touch a command line. They can just double-click that, and everything is set up and running for them. So this brings me to my last point, which is that we are very fortunate to work with a medium that we can build our own tools with. Most industries don't have this. Most people can't build the tools that they use to build their day-to-day projects. So I encourage you to really build your own tools. Grunt makes it really easy. It's one way of doing it. Regexer, which I showed you briefly, is an example of a regular expression tool that I built just because I thought I needed a regular expression tool. And it wound up, we wound up sharing it with the world, and now about 10,000 people a day use it to learn regular expressions. We're just starting to investigate some tools like Node WebKit, which takes sort of the power of Node.js on the desktop and puts a WebKit browser on top of it and lets you create installable applications that uses all the skills you already have. So it's an entire desktop application built inside of HTML and JavaScript. So build cool stuff. That pretty much wraps me up. This is the list of all the tools that we went through. Again, feel free to snap a shot of that because there's tons of information online. And I hope that walking away from this talk, you found at least one tool in here that's genuinely useful to you and will save you some time. Thank you.